Okay, today we're going to talk about section 8.6, factoring trinomials, where the a value is not equal to 0. Sometimes you'll also hear us say where you don't have a lead coefficient. Those mean the same. Excuse me. Those mean the same thing. Now, before we do that, though, let's do a little bit of review. This is the type of factoring we did earlier before we went away to break. We talked about how to factor this trinomial, and we said, well, we're going to start out with just some parentheses here, and we're going to plug some things in. We said the terms that go here come from the x squared, so the factors of x squared are x and x. And then the factors of 8 are 4 and 2. And I asked in class, how do you know if that's right or wrong? Well, we said two things. One is that 4 times 2 has to equal 8, and that 4 plus 2 has to equal 6. Now I'm going to go back a little bit on what I said before, and that's not exactly the correct statement. The way you really tell to see if these are factored correctly is a little more complicated than that. And the way you do it is this. You simply multiply the inside terms together. So this 4 and x. 4 times x is just 4x. And then I multiply the outside terms together. 2 times x is 2x. And if I add those together, those should add up to that. And they do, so we did it correctly. Right, and that's really the way that you go through and you check these trinomials on whether or not you've factored them correctly. So let's look at this one. So for instance here. So factors of x squared are x and x. Factors of negative 15. Now let's say I chose positive 5 and negative 3. Positive 5 times negative 3 does equal negative 15. Then multiply these inside terms. So that's 5x plus the outside terms. It's negative 3x. Does 5x plus negative 3x equal negative 2x? No, it doesn't. It actually equals 2x. So that tells me I did something wrong. So looking back up here, what could I do differently? Well, maybe if I just change the signs here. If I just made this a minus sign right here, and this a plus sign. If I did that, the inside terms would give me negative 5x. The outside terms would give me positive 3x, which would be negative 2x, and I've done it correctly. Now, as I warned last time, or when we were doing these before, that factoring gets more complicated, and today is the day that that happens. By no means do I expect us to be perfect by the time we're done doing just these 4 examples right here, but hopefully we'll have a little bit of an idea. So that way when we get into class, we start doing lots of examples, and that's what it really takes. It takes lots of examples for you to really understand how to do this. You can't quit, you can't get frustrated, you just got to keep trying. As I said before, this factoring of trinomials is one of the most important topics of this second semester. So let's try this one. Now obviously this is different because this has a 6x squared, and while none of the other ones before had a lead coefficient, which reminds me that this actually should say a is not equal to 1, not 0. Sorry about that. It's kind of silly. All right, so let's take a look here. So this time I need to use factors of 6x squared and 2 and combine them together so that they add up to 13x. Because obviously if I just did this, there aren't any factors of 2 that will add up to 13. There aren't any factors of 6 that add up to 13, but I should be able to combine the factors of 6 and 2 to come up with 13. Now how do I do that? Well, the way I always do it is this. I like to write up here my factors. So factors of 2 are 1 and 2. Factors of 6, I have 1 and 6, and I have 3 and 2. So the factors of this one still go in these 2 spots. So since it's positive 2, I'm just going to put plus 1 and plus 2. Now the question is, what do I put in the first spots? Before we just put x and x, but now because it's 6x squared, I either had to put 3x and 2x, or I had to put 1x and 6x. So the question is, what ones do I put, and where do I put them? Well, let's just say I just picked 1 and 6. If you don't know, just guess. So let's put a guess. So instead of 1 and 6, I'm going to put 1x and 6x. Now, did I do that correctly? Is that the correct factorization? Well, we check ourselves by simply we multiply these inside numbers together. 1 times 6x is 6x. Multiply the outside ones together. 1 times 2 is 2x, that is. 1x times 2 is 2x. And those add up to 8x. Well, that tells me I did something wrong because I needed to add up to 13. So, instead of just dumping 1 and 6 and going to 3 and 2, what if we just switched them around? So what if I put the 6x first and the 1x second? So how does that change things? Well, so since we know this one is not right, let's try it again. 1 times 1x is 1x. 6x times 2 is 12x. And that adds up to 13x. And that's what I need. And there you go. I just factored it correctly. Now, is this an exact science? No, by no means. It takes a lot of guess and check. Now, the only bright side, I guess, is the more you do these, the better you get. Eventually, believe it or not, you'll be able to do these in your head. But it definitely takes a lot of practice. So let's go down and try another one. Okay, so I'm going to start out just by putting my parentheses here. And then the second thing that I like to do is I just like to list my factors. Well, we got 2 and 1 and 2 and 1 again. So since I only have one choice here, I'm just going to put 1 here and 2 here. It's going to be positive again since this is positive and that's positive. And now again, it's just a guess as to which one, not really a guess, I mean as you get better you'll know, but right now it might be a guess. So, take a shot. Which one do you want to put where? Do you want to put 1y here and 2y here, or the other way around? Well, what if I put 2y here and 1y here? Okay, and obviously you don't need to put the 1 in front of the y right there. And how do we check? Well, we check by simply multiplying the inside terms. So that's 1y. 1 times 1y is 1y. By the outside terms, which is 4y. Add those together, we get 5y. We did it just like that, very first try. And sometimes it works just like that perfectly. Other times it takes many efforts at it. As I've said many times, it's not an exact science. All right, let's try another one, number 3 down here. A little more complicated. So I'm going to start once again. All right, now, very first thing we should notice is this is a minus sign right here. So what does that mean? Well, that tells us that my factors of 8, one is going to have to be a positive, and the other one's going to have to be a negative. So that's a big deal. And if you don't know off the top of your head what you want to use, I'm going to list my factors again. Let's see, I have 1 and 8, and I have 2 and 4. And over here I have 1 and 7. So I don't have that many choices here. Okay, but because we have plus and minus here, that makes a difference. So let's see what we can work out here. Let's start over here. Okay, what do we want to try? 1 and 8, 2 and 4. I don't know about you, but to me it feels like we should probably use 2 and 4. So I'm just going to put the 4 here and the 2 here. And if you don't know why, then you know what? It's just a guess. Just put it down there and see what happens. That's why we have erasers. Don't worry about making a mistake right away. Now, what about the 1 and 7? Well, let's just put it down. Let's see what happens. So let's say 1x, and let's put 7x here. And let's see if that will combine to be negative 26x. So inside, That's 14x. Outside gives me negative 4x, and I can see right away that's not going to add up to that. So we got to do some moving of stuff. You know, it might mean we have to use 8 and 1, but it also might mean that we just simply have to move some of these things around. Now you notice that this is a negative 26. That's a pretty big number. You know, we didn't get anywhere close to that. So what if I took my 7x and my 1x and switched those around? What would happen? So that's no good. All right, so let's try this again. So 2 times 1 is 2x. And 7x minus 4, or 7x times negative 4, is negative 28x. And you notice that's actually pretty close to negative 26. And if you do 2x minus 28x is negative 26x. And there you go. That's my factors. We haven't mentioned this so far in this set of notes, but how would I check to see if those were actually the factors? If I really wanted to test it, well, you could go back and just FOIL that out. And if you FOIL that whole thing out, you'll end up back with that trinomial. Okay, last one. And like I said at the beginning, I don't expect you to be perfect at this, but hopefully you're starting to kind of get an idea. So let's take a look at this last one. Let's start with some parentheses here. I'm going to list my factors. Factors of 6 are 1 and 6, 2 and 3. Factors of 3 are just 1 and 3. And again, notice this is a minus sign, so this is telling me that one's going to be positive, the other one's going to be negative. So, what do we want to use? Okay, this would be a great time for you to just hit pause and see if you can do it. Alright, so my suggestion is I'm going to actually use not the 6 and 1, because as I look at 6 and 1 and I think 3 and 1, when I combine those together, I don't really see how I can ever get 7. So I'm actually going to use 2 and 3 here. I'm actually going to put the 3 here and the 2 there. Now, my 1 and 3 for the x squared, I'm going to put an 1x here and a 3x there. And let's see if that works. So, multiply the inside. That is 9x. Multiply the outside. Negative 2x. And yep, that works. So I factored it perfectly. Okay, so like I said, it's not an easy thing to do. I don't expect you to be great at this by the time I see you. But hopefully you're starting to kind of get the idea of you have to combine some factors of the last term and the first term to come up with that middle term. And it just takes a lot of practice. So if you have questions, which you probably do, you know, make a note to yourself about that, and then we will talk about that tomorrow. Okay?